response question to practice with me today. Um, in this question, you're given a graph, and the graph of the function f consists of 3 line segments, and my printer is running out of ink, and I got to figure out if that's essential right now or not, but it's running out of ink, so I'm going to deal with it and draw this in. And there's a quarter circle in the middle. So I see the 3 line segments, and there's a quarter circle in the middle. And then it defines g using that graph. So it's the integration of that graph from 1 to x dt. So first it says find the average rate of change. That's Iroc. That's just simply slope formula from algebra. So I remember that. So if I'm going to do that, that's going to be, in this case, from -5 to 5. That's my denominator, by the way. So it'd be 5 subtract -5, or 10. That's simple. Then the numerator is plugging in for g. So that'd be g at 5 subtract g at -5. So in order to do this, I need to plug in 5 to begin with. Then subtract, and then I need to plug in -5, and we'll talk about that in a second. So there's step number 1. All right, so first, can you integrate from 1 to 5? So again, there's a 10 in the denominator. Can you integrate from 1 to 5 off a graph? What does that mean? So that means you're going to find the area from 1 to 5. So here's 1, 2, 3, 4, 5. So could you find the area, and that's a trapezoid, so I'm going to treat it like a trapezoid. Could you find the area of that trapezoid? So it's 1/2. The bases, 1, 2, 3, 4. The top base, 2. And then the height of the trapezoid, 1, 2, 3, 4. So there it is. You could simplify it if you had a desire to, but you shouldn't, unless you really have time to do that. And that is 6 times 4 divided by 2, or 12. Now the second part, a little more challenging. 1 to -5. And notice that normally the greater number is on top. And that's what we're comfortable with. But you could have an integration where the lesser number is on top. And we're still going to integrate with the graph. Just whatever answer we come up with, it is the opposite number. So when this is flipped, all you do is the same work. So we're going to go from -5 to 1. Just what answer we get, we're going to do the opposite number of that, and that's all it does. So if I want to write this where -5 is on the bottom and 1 is on top, it's just the opposite answer to whatever answer I'm coming up with. So I'm okay with that. So I'm going to go from -5 to 1. So 1, 2, 3, 4, 5. So here's -5 to 1. So what I notice is all of this is below the x-axis. So all of this would be a negative answer. But because the integration bounds have been flipped, our answer is actually going to be the positive answer of that. So let's see what we can do. What do we see? So first of all, I see a triangle here. So half the base times the height. So the base is 1, 2, 3, and the height is 1, 2, 3, 4. So I see 1/2 the base times the height. I'm going to do it like that. I'm going to keep going. Now normally that would be a negative answer, but it's a positive number because of that, the bounds. I see another triangle here. 1/2 the base times the height. And then the last thing I see is a quarter of a circle. And this quarter of a circle, you can tell the center is at 0, 0. And the radius is 2. So how do you find the area of it? And whatever the area is, which is pi r squared, we divide it by 4 because of that. So the radius is 2. So it's pi r squared, but I divide it by 4 because it's quarter. There it is. Now, 4 divided by 4 could leave you just with pi. You could simplify this as 6 plus 1, which is 7. So really the answer here is also 7 plus pi if you simplified it with a subtract sign in front with parentheses. But this is also a good answer. So you see two triangles, a quarter of a circle using the radius, and that's the average rate of change. All right, B. Instead of that, find the Iroc, and this Iroc is when x equals, oh, my printer didn't say, at x equals, let me just look this up real quick. So when x equals 3. There it is. All right, back here again. So what's happening at x equals 3? So 1, 2, 3, I see it. So at x equals 3, what do you notice? From the left and from the right. So first of all, g, instantaneous, we first have to take the derivative. So at g at x equals this, then if I want the derivative, and this means derivative, I have to take the derivative. So when you take the derivative and the integration, they undo each other, and then you plug in x, and it becomes just a simple substitution. So the derivative of g just equals f at x. When you plug in 1 and take the derivative, the answer would be 0, so there's nothing here. Subtracting 0 wouldn't help you any. So it's just f at x. Then when it says find the derivative at 3, all you're doing is looking off the graph and say, what's the value of f at 3? So now when I go 1, 2, 3, go up here, I can see, oh, the value is 4. That's the y coordinate off the graph, and you have the answer. All right, turn the page. For the next page, I'm going to keep this here beside me. It says, on what open intervals, if any, is the graph of g concave up? So we just said the derivative of g is f at x. We just did that. Concave up deals with the second derivative. So I'm going to take the derivative again. And now I need to know that I'm looking for when the derivative is, so I'm looking for when the derivative is greater than 0, g at x is concave up. So when the derivative of f is bigger than 0, the g is concave up. Now when I look off the graph, all I'm seeing is where is the graph increasing? That's all I'm looking for. That's what it means. So what intervals is it increasing? That's where g is concave up. So let's look back on the graph again and just think, where is it increasing? So first of all, it's increasing from negative, what is that? -5 to -2, because it's going up there. And what other interval is it increasing? From 0 to, is that 3? So looking off the graph, where is the graph increasing? From -5 to -2, from 0 to 3. And where it is not increasing, it wouldn't be concave up. All right, last question here. D. Again, the printer, my printer, having some issues. It left out some things here. So find all x values in the interval. Let's go back here, make sure I am writing this properly. So from -5 to 5, so that's the whole graph. Any other point that missed out here? Okay, so we go back again. Find all x values in the interval from -5 to 5, at which g has a critical point, and then classify each critical point as a minimum or a maximum or neither and justify your answer. So for g, I would have to take the derivative, or where is it undefined, to understand the critical points. So we already said the derivative of x is f at x, and we're going to make it equal to 0 or where it's undefined. Now, it's defined for the whole graph from -5 to 5, so there's nothing that is no discontinuities there. So when is the function equal to 0? That's another way of saying where are the x-intercepts. So we have critical point at x equals, and we're looking off the graph where the x-intercepts are. So it touches the graph at -2 and when x equals +1. So those are the two critical points. Now if we do a number line for the derivative of x at -2 and at 1, it might help us better. When I look at the function and the derivative, I'm just looking for where it's above and below the graph. So less than -2, it's below, it stays below, and then after +1, it goes above. So this is below the graph, and then above the graph. This tells me decreasing, decreasing, and increasing for the function g. So if I want to know at -2, is it a minimum, a maximum, or neither? You can now see at x equals -2, it is neither a local max or minimum because g at x decreases from -5 all the way to 1. So there's no change. Now, at x equals +1, what happens? So we go from a negative to a positive, so it goes decreasing, increasing. That creates a minimum. So at x equals +1, there is a local minimum. Why is there a local minimum? Because at x equals 1, g at x changes from decreasing to increasing. Beautiful calculus words. Decreasing and increasing, continuity, and so on. So at x equals -2, there is neither a local maximum or local minimum because there's no change. It stays decreasing through that whole interval. And then at 1, you can see there's a change from decreasing to increasing. So therefore, there's a minimum at that. All right, that was your free response question with me. Anyways, I'm proud of you. I know it's challenging, and you're making a great choice. Mr. G Math, over now.